Hello and welcome to this second interview with William Kinimonth. As we discussed in the first interview, which was for rural valuation primarily, William Kinimonth is a former head of Australia's National Climate Centre. And I won't go through the rest of your bio, William, because the people that are watching this can look at the other video, and I rather hope they do. And suffice to say that you've certainly been actively involved at what appears to be the higher end of Australia's involvement in climate science over a very interesting part of when our concern about the environment and climate change and so on has been developing. And so having the opportunity to speak with you is very valuable, and I appreciate your time very much. Now, we're going to be looking this morning at the implications for our current concern about environmentalism and sustainability and so on as applied to urban property and some of the issues that come along with that. And so what we might talk about is things like green buildings and the other things which affect urban real estate as we go along. So that's a fairly open agenda. Just to begin with, Australia is very conscious of ensuring that our commercial buildings are green friendly, and my students will be looking at the neighbours' ratings and managing properties in that regard. Now, from a climate sciences point of view, could you give us an outline of the relationship between our concerns about energy efficiency and green buildings and so on, and a meaningful impact on the environment?
Well, certainly, Gareth, there's a number of issues that we talk about in terms of the climate. One is the sustainability of the building. In other words, it has got to be able to withstand serious weather and climate extremes. And Australia, of course, has got a whole range of climate regimes, whether you go from the tropics down through the middle latitudes down to Tasmania. They're all quite different. So you've got to, there's no one size fits all. So you've got to look at the climate that you're building for and sort of make various judgments about that. Now, one of the things that we'll start in the tropics is that if you want to be energy efficient, you have a very light mass, and so the air can come through and so forth. But on the other hand, if you have a light building, when you have these very strong winds, hurricanes and so forth, it'll probably get blown away. So it's not an easy issue. I remember I was up in Darwin in the middle of the 1960s, living there in a house which had louvers and so forth. It was very pleasant because the air would come through. Tracy came through and took all those houses away, and they rebuilt Darwin with sort of concrete and cinder blocks and large mass, so that when the sun heated it up, it got very hot. So you really needed air conditioning, which from that point of view is not very green. So it's a very much more complex thing. Whereas down in Tasmania, it's the cold that you've got to be concerned about, and you've got to be able to conserve heat, and it's quite a different way of doing things. I might just mention that when I was in Geneva, they actually rebuilt the World Meteorological Organization building, and they had energy efficiency, green building in mind. And I guess if you're not aware of it, it's good to go and look at how they designed that building, because facing south, there was a whole bank of louvers, and those louvers could be adjusted with the sun, and there's also windows that could be open. So in the summertime, and it did get very warm there, air could move through. In wintertime, you could close it up, open the louvers up to get the sunlight in, but close the windows. But also the air conditioning was essentially, they were fortunate near a lake, and they were able to have a large water body that they could use as a heat bank, and pumping water through the part of the lake and back up into the building to keep the temperature fairly warm. So there's innovations that can be done to buildings depending on where you're located. And there's no one size fits all, but you've got to be ensure that you minimize your electricity usage. And the other thing is that you don't want to make it too flimsy that it gets blown away in extreme weather. I might say also they had a very innovative thing there that for the lighting in the building, that if you move, the light would stay on. So if you're stuck there reading a book of some sort and you didn't move, the lights will go up around you after a certain time. So there are certain disadvantages. You've got to be aware that when you're reading a book, you move your head a little bit every now and again. But there are these techniques and technologies that are around that can make things much more efficient and useful. But building for the different climates is important.
Okay, now that sounds like something a bit more than simply having a more efficient air conditioning system and so on. What you're really saying is that designing buildings so that the air conditioning is not needed as much.
Yeah, and when you're building a new building, remember that a bit over a metre down into the ground, temperature hardly changes during the year. And so if you put pipes down there with air running through, or water or some other fluid, you can use that as a sort of a heat bank and sort of minimise the amount of energy that you're using. So there's all sorts of things that can be taken into account.
Oh, that's interesting. And certainly what you're saying about the older buildings in Darwin, it seems that some of our old approaches to architecture were probably more green friendly than what we're building today. Indeed,
yes. And you look at some of the historical photographs of early pioneers in the tropical countries, and they have these buildings with shade, slats to let the air through and so forth, and very low mass so that they don't heat up and keep radiating heat, because you get uncomfortable when the building around you is hot, radiating heat towards you. And so you can minimise that, and particularly in the evening, letting it cool off and so forth. So there's a lot of things that can be, I was going to say they're forgotten, but they're not forgotten, that modern technology takes over. And I guess there was a period when there was energy was very cheap. And so you put in air conditioning, and so sort of right through America, air conditioning is what they do everywhere. Whereas in these days, when energy is not so cheap, we've got to be looking to conserve it.
That makes sense. And what you're saying about that, the building with the southern facing windows, just solar aspect, is something which still we don't take that seriously. We build something for its overall appearance rather than which way it's pointing.
Yes. Yeah, I can vouch that I'm in a building at the present time where there's lots of glass around. In the wintertime, the sun does come in, and we almost never use the air conditioning, the heating at all, because it heats up during the day and it retains it overnight. So it's very pleasant.
Fair enough. No, that's useful. And in terms of the relationship, and again, tell me if I'm taking you outside your area here. We have a number of rating systems for energy efficiency, for sort of the environmental friendliness of buildings, their neighbours, the Green Star ratings and so on. Are you familiar at all with the science that went into the development of these ratings? It's one of the things which has always interested me. While efficiency and good design is attractive, I've often wondered whether there was actually a connection between energy efficiency and changing the Earth's climate. But this is what
the connection is it's intimated that it's the more energy you use, of course, the more carbon dioxide that goes into the atmosphere, and therefore you're damaging the climate. But I think that's a lesser aspect than the livability of the building and the environment in which it's located. And the high-rise buildings that are in the city, they're a little bit of a difficulty because they're large mass, they're all one next to each other. Wind runs through them. You get these alleys that the wind blows between them and accelerates. So there's a lot of negatives about that. But in terms of where most of the people are living out in suburbs and so forth, there's a lot that can be done for those buildings. One of the important things in summertime is to ensure that there's plenty of shade, that things are not fully exposed to the sun. I'm familiar with in the tropics where a lot of the buildings have a second roof on them. The first one sort of absorbs the sunlight, and between the second and the first one, air flows through. Air, of course, is a very poor conductor of heat, and so the building underneath doesn't warm up. It doesn't get the radiation from the top. Whereas a lot of, I know the first building that I lived, or the first house I lived in when I got married, there was no insulation in the ceiling and had concrete tiles on the roof. They got hot. The cavity in the roof got very hot. The ceiling got hot, and it radiated down, and it was quite an uncomfortable house until we put ventilation in and also some insulation. So those sorts of things are important. They're not very expensive as long as they're put in earlier. To retrofit buildings does become quite expensive, but there's a lot of things you can do to make a building much more comfortable than what it was.
That makes sense. Even to do with the colour choice.
Yes, light-coloured roofs and light-coloured walls and so forth. Yes, it's dark.
I've been finding it curious, especially like in residential areas. You look at aerial photographs, and we've gone to very dark-coloured roofs now. At least in our part of history, at least what's popular architecturally in Australia.
Well, is that because of the cheapness of that sort of a roof material, or is it because of some sort of aesthetics that people prefer now than what they did previously?
That's an interesting question. That would be worth actually checking up on. I suspect in many cases, for instance, in rural areas where metal roofs are pretty much the order of the day, again, we're typically now very dark coloured colour-bond roofs, very dark greens, sort of charcoal greys, compared to a couple of generations ago when people were painting their roofs silver or just even plain galvanised. Yeah, no, it's interesting, and it really puts a different perspective on energy efficiency and I guess the Green Star rating and so on. Probably a bit of a more human element too. So thank you for that. I'd like to ask you about your thoughts on water efficiency. One of the, in our previous interview, we were looking at the importance of evaporation and latent heats and, that water cycle kind of connection. We're becoming very conscious of water efficiency for buildings, again, related to environmental management and to a certain extent the fear of Australia running out of water as a result of climate change or whatever. Would you be able to give us your perspective on where Australia is likely to be going in terms of rainfall and how that will impact on water management and for cities and so on?
Well, I think the thing we do know is that the climate is variable. We have these drought periods. We have the periods like at the present time of La Nina, where there's lots of rain around the eastern parts of Australia. And so we've got to sort of conserve during the good times to make do in the dry. I don't think there's any worry that we're going to actually run out of water. There's a suggestion that because of climate change, the dams will never fill again. I think that's gone out. Warragamba is overflowing. Most of the dams are pretty full down the east coast, and so the question is, it's not running out of water. It's the growth of population and the demand for water is increasing, and so for that point of view, we've got to be much more efficient in how we use the water. In the days of, well, we've got running water coming in. It's pretty cheap. We can use it as we wish. I think those days are gone. The price of water is going up, and so people are themselves understanding that you've got to conserve water to some extent. And so the sort of low flow showers and taps and so forth, they're all good. But also around the property, when we talk about urban properties, looking at vegetation that actually gives you shade and increases evaporation. Quite clearly, underneath trees, it's much cooler than if you exposed out in the on a grassy lawn. So giving some idea to how you actually protect the building from outside as much as what you do inside. And evaporation is very important for that. And drawing on the groundwater through trees is a much better idea than sort of watering lawns with sprinklers.
No, that makes a lot of sense. There's a move to retaining and being more efficient with the water which is available on properties now too. It seems that there's, expenses involved in water storage, water tanks, whatever.
Yes, yeah. There was a bit of a fad a few years ago when Eastern Australia was going through a drought, that people ripping out their gardens and putting in pebble gardens, and not realising that, of course, that those rocks and stones, they all heat up, and that makes the whole environment much hotter than what it had been if you've got shrubs and trees around. So you've got to be a little bit careful in terms of what you propose for the surroundings to the building.
No, that's interesting and not immediately apparent. Yeah, no, thanks for that. Now, I want to talk about sea level rise and the real prospect for sea level rise, whether we can control it, how we should be responding to it. Will our fiddling with things which, producing carbon dioxide or what have you, affect the sea level? Can we stop the sea level from changing? Because urban real estate by the water is amongst the most valuable real estate on earth, and so we spend a lot of concern trying to conserve it.
The point about sea level rise is that it's relative sea level rise at any place. It's not only is the sort of the ocean surface level moving with time, but also the land underneath is moving with time. And so it's the relative sea level that you're really concerned about. There are some places, of course, where the relative sea level is such that it appears to be falling. And that's because the land is rising up. And some of the islands in the Pacific and so forth, they're volcanic and they're still fairly active. And so the whole landmass is rising up. Australia as a continent is actually moving, and it's moving northward at about 7 centimetres a year. So it's not inconsequential. And in that northward movement, of course, that's what caused all the problems with earthquakes and so forth up in Indonesia, is because the plate is moving underneath the Asian plate and causing disruption there. But that also means that our relative sea level is changing because of the movement of Australia. I'm not sure that's those movements are very or should be as much of a concern. The sea level over prehistoric or very past times has risen because of land ice melting. And 20,000 years ago, there's much land ice over North America and Northern Europe, and sea level was 130 metres lower than it is now. And so it has actually risen until about 10,000 years ago, over a considerable depth. Tasmania was cut off because of the rising sea level. During the last glacial period, the continental shelf of Australia was only about 150 kilometres away from Timor. So the trench there is actually the separating place from the plates. So there has been a lot of sea level in the past, but over the recent couple of thousand years, there's been a lot of debate as to what sea level has done. And some people are saying that, well, there has been rise and falling of sea level. And this is as the climate has warmed and cooled from the so the Roman period to the Dark Ages to the medieval warm period to the Little Ice Age. And so there is a rising at the present time because there is melting of land ice up in the northern hemisphere particularly. It's not very much. It's almost imperceptible. There's a sea level monitoring sites around Australia and out into the Pacific. And given the natural rise and fall of sea level because of changing ocean currents and so forth, it takes many, many years to discern any rise at all. And so, again, I don't think that the sea level itself is the issue. What we've got to look at is how the coastal geomorphology, and some coasts are susceptible to erosion. And when you have storms and so forth, those sand dunes and so forth are easily eroded. I remember back in the sort of about 1968, there was much concern in the Gold Coast because there was a lot of erosion taking place from these high-rise buildings right on the water's edge. And so they had to do some works there to protect that. But that's happening all around the coast. We've got to look at where that's happening and be aware before we do any building and so forth, or any development of the possibilities. There are places in England where, as long as memory records go, the sea has been encroaching. The cliffs are quite high, but they're just falling away because of the wave action at the base of the cliffs. So it's not the sea level rise is the important thing in my view. It's what's happening in the geomorphology. And so people talk about, well, the coasts aren't like they used to be because of sea level rise. No, it's essentially because there's been erosion taking place, or there's been development taking place, like groins have been put out where so the erosion is taking place in different places, and that's all got to be taken into account when you're looking at a coastal property.
Now, that makes a lot of sense. And what you're saying about the Gold Coast example, while that's history now, I think it's useful for people to be aware, especially interested in coastal cities. The way that in the 50s and 60s, as I understand it, the whole behaviour of sand dunes and the beach systems wasn't understood. And it was only with problems like the Gold Coast, and no doubt other parts of the world as well, that science actually turned its lens on what was going on, that you really shouldn't be building tall buildings just behind a beach, even though it's a very attractive place to build a building.
Unless you put in protection, which is a lot of technology.
No, exactly right. And a lot of these systems you don't understand until you've actually done something and then found that it doesn't work the way you expect. No, along the east coast of Australia, it was popular, this is when we still had a fishing industry, to build the breakwalls out from the rivers, and that was supposed to make it safer. And now it seems that the effects on sand movements and so on around the mouths of the river has been far more complex than was appreciated, and in some cases caused as much problems as they've solved.
And of course, there's council disputes with people who are actually living on the coast who are wanting to protect their property against this natural erosion that's taking place. And the council is saying, no, that's sea level rise. Well, you've got to live with that. And there's all sorts of issues. But it's not just sea level rise, it's the erosion and other aspects that are taking place that have got to be taken into account.
That makes sense. I'm not sure if you're aware, in property law, there's a principle of accretion and erosion, which is where usually you apply it to rivers. Rivers change their course over time, as you'll be aware. And in property law, if the change is slow and imperceptible, then whether it's a plus or a minus, you either benefit from it or wear it as just a natural change. So you might have 100 acres and it might become 150 acres as the river changes. If the river changes, as a result of a flood or whatever, it's a different story. But this historical recognition, our land law goes back, centuries in English history especially. It seems that people are always aware of these things, and it's only in the last little while that we've suddenly become a bit more precious about it. The sea level rise continues to be a concern, but what you're saying is that it is quite a minor issue, especially compared to the change in the geomorphology around coastal areas.
And also, so for example, in the east coast or northeast coast of Australia, there is considerable rise and fall of the sea level due to climate events. And when we have an El Nino event, water rushes from the Western Pacific across the equator to the Eastern Pacific, and sea level actually drops by about, in 97, 98, it was 35 centimetres that it dropped. And in the East Coast, over at Galapagos Islands, where they've got a monitoring, it rose about 35 centimetres, only for a few months. And I was out at Samoa at the time, and there were reefs in the bay there that nobody can remember having seen them before, because the water had dropped and gone. That's just natural, and it came back again. But we've got to be aware that those sorts of changes take place.
My goodness, I didn't realise that it was that great. That is really impressive, and I appreciate you putting numbers around it. There was numbers in 30 centimetre range. That's not insignificant.
No, it's about a foot. The old language, yes.
I know in my surveying days, we take an interest in sea level, like levels are always referenced to sea level. And there was a project, this is going back to the 1970s, of developing a uniform height datum for Australia, which was tying together sea level around the country. And that ended up becoming, it was a statistical average. And so our Australian height datum, HD, is not exactly sea level, but it's kind of an average of something like sea level, more or less, that everyone agrees in, simply because I think that exercise itself helped us to understand some of the complexity you're talking about. And that was a matter of literally getting surveyors working from Darwin to Adelaide, doing precise levelling and so on. A very difficult job. We take these things for granted, but I think science in living memory has improved our understanding so much. I mean, we take GPS on our phones for granted now, right. Google Maps. In the 1970s, that stuff was in its infancy and was being used to establish whether Australia was encroaching on Asia or not.
Yep.
So this is very new science, really.
In the late 80s, I think it was during Hawke's prime ministership, Australia volunteered to put in a sea level monitoring network in the Pacific, and the tidal facility at University of Adelaide took on that job. And there was very complex instruments put out there to do that, but the biggest part of the whole project was actually the ongoing surveying of the height datum of the instruments to see how they were moving relative to some point, maybe in Central Australia, or I don't know where it was, but they were all moving relative to each other. And then you had to work out what the sea level was doing. So it's not an easy task.
No, you're right. And you're reviving my memories from when I was a surveyor and doing geodetic surveying, which is surveying over a large enough part of the Earth's surface, you have to take into account curvature.
Yes.
We were involved in doing gravity studies, yes, because gravity changes in locationally, and that will then affect many things about your estimate of where you are. Even the idea that the Earth's magnetic field is shifting in ways that we're only, on the edge of understanding well. And that could have enormous effects on many aspects of the way that we live, not just pulling out a compass, but gravity influences many material and even biological systems. We live in an interesting part of history. Thanks for that. Now I wanted, we've covered a fair bit of these climate interactions, and it's been an interesting period. And I think you and I have seen, a lot of development in science. I know in the 1980s, and when perhaps you were involved in the International Commission on Climatology and so on, a lot of these were very live questions. But it seems that while the questions were posed in the 70s and 80s, by the time we get to our part of history, we've got a lot more information, and yet we're still acting as though we've got the same problems. I'd be interested in your thoughts on the way that discussion has changed.
Yeah, well, it's changed considerably, and you're right. In the sort of the 80s and 90s, when I was involved in the World Meteorological Organization's Commission for Climatology, we were interested in climate variability, how climate changed from year to year and from decade to decade and so forth, and taking those things into account. And we knew that when you have an El Nino, you have droughts in some places and very wet in others. And so quite different issues came up in those different communities. Where it got wetter, of course, you had floods and whatever, but you also have diseases because of the mosquitoes and water sitting around and so forth. Now, a lot of people were involved in that, and we sort of linked into university people in various disciplines. Urban and building design and so forth was one of the focus that we were looking at, how best to design buildings for these particularly developing world countries. But then around about 2000, everything changed. Global warming seemed to be the thing. Everything is due to global warming. What do we do when the climate changes to whatever it's going to change to? And so all this interest in adapting to a changing climate has shifted focus to how do we adapt to a warmer world if it gets warmer. But I spoke before that I don't think it's going to get very much warmer very quickly. And so we're still living with all these variability that provides extreme weather events and climate events. And we can't forget those when we're dealing with all of the problems of society, whether it's in agriculture, whether it's in building design, or whether it's in water management and so forth. So you're right, there has been this change of thinking. And it was interesting that all the university experts who we were talking with about climate variability, all of a sudden their interest was in climate change, because that's where government money was coming from to do those sort of studies. And we seem to have lost touch with the fact that our climate is changing. We have these weather and climate extremes. We've got to be prepared for them, and we've got to build and invest for the changing, for the variable climate, and not be surprised when you get a weather extreme.
Thank you, because it does seem that science, or at least the activity of scientists, follows the funding, and that's become probably more evident in the last couple of decades.
Yeah, there was a lot of money in early days in climate variability projects, and Queensland government, the CSIRO, the Bureau of Meteorology, the Australian government, they're all looking to how to better predict and understand the climate variability, particularly for rural people. And that seems to have, all these money's dried up and it's gone into these other things. But how do we prepare for climate change, which we don't know what's going to happen anyway? We've got models, but I'm not sure that I really believe, because so many of the models have different projections. Some say it's going to get wetter over Australia, others say it's going to get drier. So, but we do know that it's going to be variable.
I was doing some background reading for a project on sea level rise and urban land values, and the CSIRO, and I can't remember the year of the study, but they did a meta-analysis of the sea level rise predictions. And I remember there was one just marvelous quote. The studies vary in both magnitude and direction.
Indeed.
I thought, crikey, here we are thinking about, sea levels rising, and some of these models are saying they're falling, and, it's all over the place.
Well, I think in the near future, the sea level will continue to rise, because as it gets, we are on a warming trend. And until we get to the cusp of that, we'll still get melting of sea ice, of land ice up in the Arctic. And Greenland has got a lot of ice to melt. You may not know that the last interglacial, which is about 120,000 years ago, there was very little ice left on Greenland, that almost all the ice left. And so sea level was at least 2 meters, and some people say about 3 to 4 meters higher than what it was now. But talking about sea level, it takes that much melting of land ice to raise the sea level appreciably. So I can't see in the near future all of Greenland's ice melting. There's no sign of that happening. And so these predictions of, sea level is going to rise a meter or whatever, where's the water going to come from? So
that seems to be a very important question, where the water's coming from. That makes sense. I remember I was actually sitting in the audience of one of my learned colleagues talking about town planning for Sydney, and he put up a plan, like a map of Sydney under 12 metres of sea level rise. And of course that, got some oohs and ahs from the audience, and I'm sitting back thinking, my goodness, that's an awful lot of water.
Our data seems to show us that it's the northern hemisphere that is melting more than the southern hemisphere. The Antarctic, there's actually conjecture as to whether it's warming or cooling. There are certain parts of Antarctica, the Antarctic Peninsula, which clearly has been warming over the last few decades, but the majority of it, there's dispute as to whether it's even changing very much. Some say it's warming, some it's cooling, but I don't think the data is good enough to tell us either way. So the melting of Antarctica, which is going to get these 12-meter sea level rises, is not on the horizon. What is on the horizon is mountain glaciers and to some extent Greenland. And they're monitoring Greenland. It is melting to some extent, but not a significant amount.
That would still translate to centimetres or maybe decimeters, rather than meters, I'd imagine.
Well, the amount that it's melting, Greenland is melting at the present time, it really is sort of millimetres a year. We're saying that it's about 2 millimetres a year according to the tide gauges, according to the satellite, which they have problems getting ground truth. The relative rise is about 3 millimetres a year from them. Yeah, so
fair enough. So that still means 300 millimetres in a century.
Yes. Yeah.
From a real estate point of view, and this is where the urban economists are concerned, and one calibrating influence which is useful to keep in mind is that buildings are considered to have an economic life of about 40 years. In some cases, some of our facilities, we might bring that down to about 25. And it's not uncommon, well, not unknown, to see buildings like commercial buildings being bulldozed that are only about 25, 30 years old.
That's right.
Now, if you use that as a calibration, so let's run that out to 50. It means if we build something now, let's say by the coast, in 50 years' time, we're going to be pulling it down or doing something fairly radical. If the sea level was to rise, go to extreme, let's say it's a metre in a century's time, well, there's going to be a different building there, and it's going to be about ready to be pulled down anyway.
And you would have seen the amount of rise of sea level in the interim, so that you can prepare for the next level going up. Yes.
Yeah. No, that's all.
It's sea level rise to me is not an issue. It's the sort of the coastal erosion and all those sorts of things that are going on around, which you've got to be very much aware of.
Makes sense. And that really references an engineering problem rather than some global catastrophe to a certain extent.
Yes, yes.
Fair enough. No, that's good. And are we asking the right questions with our interests in environmental sustainability? Our preoccupation with controlling carbon dioxide and so on. Is that the right question at our part of history? It might have been in 1980, but it sounds like we're still asking the questions that have only been answered and answered in the negative from the way you describe it.
Well, I don't think we are asking the right question, in the sense this fear of a climate emergency is focusing our mind on all sorts of things which probably won't happen. And so there are things happening around us which we should be very much aware of. And our environmental concern is not misplaced. We've got to protect our environment. We've got to have a sustainable future. We don't want to utilise resources that are unnecessarily, because if we utilise a lot of them now, they're not available for future generations. So we've got to be very much aware of those sorts of things. But we've got to be level-headed about it, in the sense that, well, how much is climate changing? Do we prepare for that? Yes, we know it's warming a little at this stage, but we know that at some stage in the future, there's going to be a change. We know that the things that make life very important, probably three. One is somewhere to live that protects you. We've got to have water to drink and to grow food and so forth. And we've got to be able to produce food. And so those are the sorts of things which are the focus for our sustainability for the future. We've got to have energy. Energy is what has brought us out of essentially poverty. And we see this in China over the last several decades, that they've accessed energy and they've got new technology, and it's lifted people out of poverty. They've still got they're self-sustainable in foods and so forth. So we've got to sort of follow those sort of paths for a sustainable future without being distracted by this business about, well, we've got to do everything to stop climate change. Because in my view, the climate is changing because of ocean currents and so forth. We can't stop what's happening in the oceans. We've got to live with those changes. And we've got the experience from the last 10,000 years during the Holocene of how climate has changed sort of over the sort of 1,000-year time cycles. We've got the shorter term cycles of El Nino and La Nina and so forth, which have great impacts. We've got to live against those. There's weather extremes, heat waves and bushfires and so forth, which we've got to protect against. And but the slow change in climate is something which we can adapt to, I believe, without too much problem.
Excellent. Now that is a very nice note, I think, to finish up, because it's both optimistic but also gives us a realistic agenda for what we should be looking at.
Yeah, well, I look back over sort of nearly 80 years now, Garrick, and I'm optimistic about the younger generation. Got smart young people coming on, and they'll see the fallacy of all this rubbish about climate change pretty soon. But we are doing better now than we have ever done in the past, and future generations will adapt. And I'm sure this energy seems to be the issue, and they'll find ways through that as well.
Excellent. Well, thank you very much, William, and thank you for sharing your experience and really your deep understanding of these things with us. It certainly provided a very welcome perspective and also showed us the complexity of what we're working with. So thank you very much for your time.
Most welcome, Gary.
Thank you. And I think we'll finish it there.
Good. Thanks.